One of the many distinguishing features of our time is the availability of really good popular science summaries written by top men in various fields, and none of us should neglect these, no matter what our own fields are. Any field of serious study today is necessarily highly specialized, and at the same time it calls for branching out into related fields. These summaries go far beyond the popularizing of another day. Because of our marvelous processes of photographic reproduction, magnificently illustrated books on every branch of science are now available. For example, recently I looked at P.T. Matthews' The Nuclear Apple, and before that, it was the biologist Lyle Watson's book, Supernature, and before that, Nigel Calder's broad survey of recent studies of the brain called The Mind of Man. That same Nigel Calder, who works for the British Broadcasting Corporation, goes all around the world getting up television programs of very high caliber. Thus, while surveying recent astronomical developments, he consulted with major astronomers in every part of the world, and so built up the programs. The last one was called The Violent Universe. It was required reading in our honors program, and probably still is. And he recently has put out one on the new geology, plate tectonics, which he calls The Restless Earth. The data of these books is significant. The Violent Universe, Restless Earth, and Supernature, that is not the way I heard it when I went to school. In my day, everything was pretty well under control. At best, we had a tolerant scientific smile for anything suggesting catastrophism or any dramatic or spectacular event in history or in nature. This kind of stuff smacked of the apocalyptic visions of Mormonism, things classed in the lunatic fringe, apocalyptic sensationalism. There was no place in modern thinking for that sort of thing, yet in all these books, regardless of the fields, authors today seem to be saying much the same thing. They all come to one very interesting conclusion, which a few quotations will make clear. First, one basic proposition receives particular attention in all of them, the well-known second law of thermodynamics. Everything runs down. And it is stated with strong and bemused reservations because there is something wrong with it. Let us quote Watson, the biologist, and I understand he has a great reputation in England. Left to itself, everything tends to become more and more disorderly, until the final and natural state of things is a completely random distribution of matter. Any kind of order is unnatural and happens only by chance encounters. These events are statistically unlikely, and the further combination of molecules into anything as highly organized as a living organism is wildly improbable. Life is a rare and unreasonable thing. He belabors the point. Life occurs by chance, and the probability of its occurring and continuing is infinitesimal. There is no chance of us being here at all. Furthermore, the cosmos itself is patternless, being a jumble of random and disordered events. It is not just life that is improbable, but the fabric of life itself, matter. The nuclear physicist P.T. Matthews asks, why is the proton stable, since this is clearly crucial to the world as we know it? From the atomic point of view, the proton is one of the basic building blocks. Yet from the behavior of the other hadrons, there is no obvious reason why it should not disintegrate into, say, a positive pion and neutrino, which is not forbidden by any conservation law. The only two stable hadrons are the neutron and the proton. The neutron has a mean lifespan of 3 × 10⁻³ seconds, about 50 minutes. All other hadrons have mean lifespans of from 10⁻⁸ to 10⁻18 seconds. Matthews goes on to explain the factors that determine the stability of the proton. The rate of decay of any particle depends partly on the strength of the interaction and partly on the amount of room it has into which it can decay. To describe what he means by amount of room, Matthews draws an analogy of a room full of objects. For every object in the room there are, of course, vastly many more positions in which it would be considered out of place. When these possibilities for all the objects in the room are multiplied together, The number of untidy or disordered states exceeds the ordered ones by some enormous factor. Then he moves into the domain of the second law of thermodynamics and a mathematical description of this concept. Matthews continues, "The logarithm of the number of different states in which a system can be found is called the entropy. Thus, the entropy of tidy or ordered states is very much less than that of untidy or disordered ones." To give us an idea about the magnitudes of the numbers we are dealing with, he presents the analogy of a deck of cards. The rate at which numbers build up in the second law situation can be illustrated by considering a pack of playing cards. We can define an ordered or tidy state to be one in which the cards are arranged by value in successive suits. There are just 24 such configurations which arise from the different possible orderings of suits. This is itself a surprisingly large number, but the number of different ways the 52 cards can be arranged is about 10,000 million, 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 or 10 to the 52nd. The chance of finding a shuffled pack in an ordered state is a ratio of these two numbers, 24 by 10 to the 52nd. Matthews continues, "The relevance of this to our problem is that one may think of a proton at rest as a very highly ordered condition of a certain amount of energy, the rest energy of the proton, which can exist in just one state, strictly two if we allow for two possible orientations of the proton spin. If the proton can decay by any mechanism into two or more lighter particles, these serve to define an alternative condition of the system which is relatively highly disordered, since it can exist with all conceivable orientations. The number of allowed states depends on the relative momentum of the decay products, much as the number of points on the circumference of a circle depends on its radius. The decay interaction is the shuffling agent. If it exists and operates on a timescale comparable with the age of the universe, then by relentless operation of the second law, essentially every proton would by now have decayed into lighter particles. Clearly the opposite is the case, and there must be some very exact law which is preventing this from happening. Had all the protons decayed, there would be no stable atoms, no elements, no compounds, no earth, no life. When the biologist said that life was wildly improbable, a rare unreasonable event, who would have guessed how improbable it really was? A human being, writes Matthews, is at very best an assembly of chemicals constructed and maintained in a state of fantastically complicated organization of quite unimaginable improbability. So improbable that you can't even imagine it. So wildly improbable that even to mention it is ridiculous. So we have no business being here. That is not the natural order of things. In fact, he says that the sorting process, the creation of order out of chaos, against the natural flow of physical events, is something which is essential to life. So the physical scientists and the naturalists agree that if nature has anything to say about it, we wouldn't be here. This is the paradox of which Professor Wald of Harvard says, the spontaneous generation of a living organism is impossible. In this colloquial, practical sense, I concede the spontaneous origin of life to be impossible. The chances of our being here are not even to be thought of, yet here we are. So, as I say, in my school days it was fashionable to brush aside Paley's watch argument with a snort of impatience. If you're walking on the beach and find a beautifully made Swiss watch, you should not with Archdeacon Paley conclude that some intelligent mind has produced the watch. It proves nothing of the sort. Finding the watch only proves, quite seriously, that mere chance at work, if given enough time, can indeed produce a fine Swiss watch or anything else. Indeed, when you come right down to it, the fact that Swiss watches exist in a world created and governed entirely by chance proves that blind chance can produce watches. There is no escaping this circular argument, and some people use it. Today, Professor Matthews states the same problem more simply. If, after seeing a room in chaos, it is subsequently found in good order, the sensible inference is not that time is running backwards, but that some intelligent person has been in to tidy it up. If you find the letters of the alphabet ordered on a piece of paper to form a beautiful sonnet, you do not deduce that teams of monkeys have been kept for millions of years strumming on typewriters, but rather that Shakespeare has passed this way. But to Professor Huxley or Professor Simpson, this is sheer heresy or folly. It was the evolutionist who seriously put forth the claim that an ape strumming on a typewriter for a long enough time could produce, by mere blind chance, all the books in the British Museum. But did any religionist ever express such boundless faith? I don't know any religious person who ever had greater faith than that. Yet serious minds actually believe such an impossibility. They say it is impossible, but then it happens. Remember, the decay interaction is the shuffling agent, and by the relentless operation of the second law, essentially every proton would by now have decayed into lighter particles. Clearly the opposite is the case. Now there must be some very exact law which is preventing this from happening. Kammerer's new law of seriality is in direct opposition to the second law. There is a force that tends towards symmetry and coherence by bringing like and like together. That is a very interesting point. We say that light cleaves unto light, etc. What is that force? Nobody knows. They say it is there because you see it working. Buckminster Fuller calls it syntropy. The greatest Soviet astrophysicist today, the Soviets' foremost man in that field, Nikolai Kozyrev, has been working for years on this question. He claims that the second law of thermodynamics is all right, but it doesn't work. Something works against it, something stronger. He says, some processes unobserved by mechanics and preventing the death of the world are at work everywhere, maintaining the variety of life. These processes must be similar to biological processes maintaining organic life. Therefore, they may be called vital processes, and the life of cosmic bodies or other physical systems can be referred to as vital processes in this sense.